particular mechanism for that, like how it happens?
Yeah, but she's hoping that if you trust IoT data for the last such as there 6 years here. One can check it out, right? But it was 6 years, right? Not very long. Yeah, actually, although this kind of plots are high, I also press scatter. You tell you much more. So this is this contouring sometimes you don't know how much of spread is there. So just do a scatter plot and see. Of course, you don't have the data with you, right?
No, I don't.
Yeah, you do it with actual data for the last, I would say, 60 years. That's data. Okay. You are saying DMI of this year affects ENSO next year, right?
Yeah.
So plot DMI this year, ENSO next year, let's see the any connection top, right? You have 6 years of data, something should go out.
Yeah.
Yeah, that's good. Nobody else? Yeah, this is very relevant to what we discussed today. Because this ENSO is still bothering us. Okay. So we have to understand this. Yeah. So we have the data now till yesterday. Today, I just checked. Today, all India monsoon rainfall was 1.8 millimeters per day. It is as good as no rain. Okay. So we are in pretty bad shape. I want to look at the all India is 35% below normal. Okay, it's a record. In the first 15 days, I have not seen this happen. And if this continues in the next 15 days, it will be an all-time record. Because whatever I looked at, unless I made a mistake, the lowest rainfall in August was 195 millimeters. Okay, lowest rainfall. Now, average is around 260. Now, if it gets 40% below normal, it will go below 200. So we may be heading for pretty bad situation. But look at central India, minus 40%. Okay. North India, minus 30%. Only northeast, East India is plus 8%. That's the only thing that peninsula is terrible. That's why there's already a Karnataka Tamil Nadu conflict going on, because this is pretty bad. Okay. But of course, we look at the whole period, we are only 5% below average. But remember that we have 1 month more to go. If this break is a long break now, we'll see that. If it doesn't revive easily, we are going to be similar to 2015. Where also things look okay up to August 15th, then it banned. This is looking like that. And if you look at the core monsoon region, I am really amazed. On August 3rd, we had 19 millimeters per day rainfall. August 3rd, okay? In 10 days, 12 days, just plunged like that. This is remarkable. And you can argue that IMD forecast is correction. You look at the IMD forecast with GFS, it was right. In 10 days, it came down. But we still do not have a simple physical mechanism which causes monsoon rainfall, which was at its peak on August 3rd, to plunge almost zero by 15th. We don't have it. And that's worrying, because we should by now should have had it. Now we look at this is what we get, one standard deviation. You can see here 1, 2, 3, 4, 5, 6, 7, 8, for 30, 40, 50 now. 15 days of below 1 sigma. Okay. So this is going to be one of the longest breaks ever encountered, because we have one in, of course, July 2002. But even there was a small time it came back and then it went back. So this issue is very critical, and what's going to happen in the next 15 days will be very, if it doesn't revive, we are in deep trouble. Now, you look at the forecast, the forecast was correct. All the predictions are pretty close except 1 or 2 days, and today is pretty bad. Here, today's value is this one, okay? So, the GFS forecast a revival. It does not happen. Okay? So, if it doesn't happen, it will be a very serious issue. Let's hope it happens, because I'm sure there is a problem all over India. If it doesn't revive, it continues around this value. You should be getting 8 millimeters in 2nd August. If you get 4 or 5 millimeters, it will be huge. Okay. And again, I want to remind you the numbers so that you remember it. We got 86 instead of 133 in August. Okay. So if it goes like this, we have another 86 next 16 days. You'll get 180. That'll be a record below. Suppose it reverses slightly, it may go to 200, 220. Still, it will be one of the lowest August in the category of August. I looked at August. Amazingly, August was very few years well below normal. Interestingly, although I vaguely remember 40 years back some discussion, people thought August is a time for breaks. Traditional wisdom, but not anymore. There were lots of July which have done badly now. So August, most of the rainfalls are around 250, 240, and so on. So 200, below 200 is going to be a very unusual event. Now, this is what they're predicting for the next till the end of August. And if this happens, yeah, we will not be that bad because all this is average to normal. So a few more days of below normal, then it will revive. If it does not happen, then we're going to be in trouble. Now, I want you to remember this and we'll compare with our standard GFS and ECMWF comparison.
Sir.
Yeah.
Sir, do you have the last week's prediction, this prediction, so we can just understand whether the prediction was that bad or not?
No, I told you. Last week is already shown. Last week is the first one I showed. Last week's. Okay. Last week is very good. I would say this is pretty good. Okay. Even this is 1 or 2 days, it correctly predicted average around 20 mean. It's not around 3.5 to 3.5. Okay. That was very good. But now question is, see, the issue finally, if the monsoon is going to either go into a break or to revive, those are the two important things to predict. If monsoon is normal, then nothing to predict. Things are very easy, okay? So I would say this break was correctly predicted up to this point. So now in the next 5 days, we'll know whether the revival occurs or not. If it does not occur, the model is in trouble. But so far it's done well. And I want you to remember this because the forecast for the next week is revival to close to normal, okay? But it doesn't agree with GFS and ECMWF. Now, remember, this is the American GFS. This is the European center. All of them are saying extremely low rainfall in North India, West India, South India, all the way down. Only Orissa, West Bengal will be above normal, which is a standard break climatology. You look at break situation in all our past data, the system shifts to the east, that's all. 10 degrees to the east, that is the El Nino break pattern, okay, fingerprint. So, the only thing I want interesting, we'll see next week, I see a very nice local, I don't know why it is there, that's very interesting. In ECMWF, not there in GFS. Let's say next week whether this kind of pattern is really there or not. This is very unusual. Maybe there's one storm or something, God knows what it does. Okay. Now, what is the prediction for September? Now that August looks bad, one can hope for September. The answer is not good. According to GFS, prediction below normal over India, above normal here. Now, this standard break condition, the equilibrium series strengthens, and then the strengthening of just above the equator here, and then happens. So this is what they are showing. Then they normalize, but it's the same, there's no difference. And then one important is that if you do not show regions which are of low significance, then no signal here. Okay. So unfortunately, this problem has been there in all climate models for a long time. Over land, their skill is very low. Okay. And that's one thing I think we have to keep asking about why ocean, I think, provides a good boundary condition that seems to help the model. But over land, skills are very low. There is no land region where the skill is there at all. Okay? The skill is there only over oceans. And the maritime continent, of course. So, this forecast has to be taken with a pinch of salt because they themselves are not sure that skill is very good or not. Okay. Now I want to show you examples of previous breaks. So So example, the two breaks I want to show you. One in 1965, an El Nino year. 2005, not El Nino year, okay. Both of them had terrible August conditions, similar to ours, okay. And so what's interesting is long breaks, although occurs more often in El Nino year, can also occur without El Nino. So that means you're not understood what are the long breaks. Now the reason why it troubles me is, one can understand this short active and break cycle. These are mostly synoptic features. What happens when Bay of Bengal, what temperature come. But when you look at a long break, which is more than 10-15 days, synoptic event, it's something much larger. Okay? So we would have thought by now our climate models would be able to capture it, but they are not. Okay? So the point about why I'm comparing these two is, in 2005, because later half of June and early July was good, ultimately rainfall was not too bad. This is 40 millimeters below normal, which is within IMD's prediction. So we may reach there, okay, if you're going to follow this one. But in 65, bad news was June was bad, July was okay, August was bad, September was bad. Then you are at 709. Okay. So we are lucky this year, July was above normal. So that may save us. But still, everything depends on September. As a matter of fact, if you recall, I showed you one paper, they showed that the largest correlation of drought here is September rainfall. It has the biggest influence. We all think monsoon is receding, not important, it's very important. Okay. So we'll see this year whether the low rainfall in August triggers a low rainfall September. It will happen because, remember, rainfall and water vapor are closely linked. If for some reason August there is no revival, okay, water vapor doesn't build up in the column, there can be no rainfall over India. So that is the biggest challenge we will face. So this will trigger this pretty much. Here it didn't happen. Here, I was going to have a look. And August is very bad here. Then it divides, remember. So when I look at these two and understand why it did not revive here, but it divides here. Okay? That's what examining that. So 2005 was interesting because end of June, till July and September, we had good rainfall. One bad in August, a little bit here, managed to keep it close to normal. Okay? So this is a good example to look at. Now, you look at August alone, if you go by what Arindam has done about moisture budget, there's something very surprising, which is that I looked at just up to 10. I mean, I got out of a few more days, but it didn't change much. 10 days of August, anomaly of wind speed is above normal over North India. Okay? Because there's a rainfall occurring here. Okay? Only South India has had anomaly in the winds and below normal. Even here, sorry, not below normal. It's all the amplitude above normal. So this surprisingly, wind speed over Arabians is over normal. Water vapor, I'm not sure, is normal. That is, it is within the variable, is not above or below. So according to Arindam's argument, there's enough moisture coming in. Okay. But if you ask him, he'll say a lot of moisture is going out, right? That's what he will say. There's no other reason why you have to break. But why did the moisture go out? It's not clear. The obvious answer is, of course, it didn't rain in India. So whatever moisture, except here, whatever moisture came in here went out. Okay. So this is what's happening here is the issue. And I don't know whether Arindam has any ideas on that. In August. Yeah, look at it, because August is very peculiar. There is enough moisture coming in because the wind speed is above normal, whatever normal, and summer is not raining in India. It's raining elsewhere. Okay.
Yes? Yes?
Yeah.
Isn't
Yes.
the typhoon sucking the water vapor? Typhoon in the West Pacific. You know, there was an active typhoon throughout this period. And it
I'll tell you
appears
that
is
yeah,
where
that we
the
have discussed before also. I don't agree with that. It is too far away. See, the typhoon in the Pacific is so far away, it is somewhere well beyond 120, somewhere here. It is too small a system to suck whatever we hear. But I believe to be corrected. I'm just making my prejudice. So any of you can do a look at a correlation between what's happening in the, yeah, there's a strong cyclone here, you're right. Whether it can be correlated with whatever here or wind here. Yeah, I would argue, for example, I didn't do the, if you look at the graph, this anomalous westerly goes all the way to the typhoon.
Yeah.
You're right. It is linked. Okay. But whether it is preventing convergence over India, that's not clear.
Yeah.
We should
That
do
is-
a little study and find out. Yeah.
I have a small idea, just opposite.
Yes.
I have a small idea about this thing that you are showing. If the anomaly is from the BSI range, that's the 20 to 80 days, if that's the range is dominating here, then the thing is the moisture gradient that we have for the northwestern India is basically to the opposite direction of the wind. So that is towards the northwest, the moisture gradient.
Yeah.
So this kind of anomaly is actually the dry BSI kind of, looks like a dry BSI kind of anomaly. When
No, but I want to look at, see, if you want to arrange the logic, look at this, don't look at that. There you are right. The wind go like this, so this is a slightly confused one. Look at this. At 70 east, which is what I uses as a reference point, okay? There is more moisture coming in. Moisture flux coming in, not moisture flux.
yeah.
So where is it going? That's the question.
Yeah, so I was just thinking the gradient is in the opposite direction. So if the gradient is in the opposite direction, so
Yes.
this kind of wind doesn't really attract moisture. That's my point.
No, here it doesn't moisture, why not? Here wind speed is more, moisture is same, more moisture is coming in.
No, but I am saying the gradient of moisture, if you look at the climatological gradient of monsoon moisture or water precipitated water,
Yeah.
is actually the opposite direction in that thing.
What do you mean between India and Arabian Sea?
No, I am talking about the northwest. And also in India and Arabian Sea, if you just look at the total precipitable water or something like that, I mean total column water, monsoon mean, the climatological mean, that the gradient is towards the Arabian Sea. So it's
What do you mean that? What do you mean? I'm sorry, I'm thinking. Are you saying Arabian Sea water vapor is more or less than India during normal time?
no, I'm just saying the over Arabian Sea, the gradient is very sorry, the moisture is very strong, and when you just go west, say beyond 65 degrees or so, the moisture is very low, and also
This is due to adduction of dry air from there. That is forget about it. We are moving from southeast to the east or southeast.
I'm just talking about the north over 20 degrees or so, the green patch. Yeah. So here the gradient is just opposite to the wind direction. In the normal moisture gradient is just opposite to the wind direction.
I don't know. I don't follow that. I don't follow that. Sorry.
I think he's talking about this V dot that Q and
Yes.
and Q dot and Q divergence of V.
Yeah.
And these two components is right, but the contribution to the western master is over India. Primarily depends south of the 20 knot, because there is not much moisture north of 20 knot.
Right.
Isn't it? So that will contribute to this.
Okay.
Okay.
Sylvia, do you have any other comment?
No.
Okay. Yeah. Looking at, I think, looking at couple of previous El Nino events. Now, I just want to show you the kind of issue which I think should be addressed. See, the key point that not addressed sufficiently is that if the Nino 3.4 anomaly is what driving the entire circulating system, then nobody has explained why, in spite of Nino 3.4 being the source, there are years when the velocity potential anomaly is to the north of the equator. And that is very critical, because look at it, when it is equator south equator, the maximum descent occurs south. Here it goes equator to the north. So this is a point issue. Why is the velocity potential anomaly not right over where the SST anomaly is maximum? I have not seen anyone explain that. And that bothers me. Because to me, SST anomaly is the highest in Nino 3.4 region. It should have highest water vapor, must have the highest convergence there. So it must have the highest level and upper level. But again to the north. So there's some role being played by the ambient wind. I talked about last time, and I must, I told you there is a paper, I don't know whether I meant, I think, I forget now. Did I talk about last time? So Gill has a paper, I was wrong. I said Gill did not have a paper. Gill had a paper along with Phillips, published in 1987, his last paper. He died in that year. And unfortunately, the paper didn't throw any light. I looked at the paper. All it is saying is that the amount of anomaly at the surface I was talking about, even with 10 meters per second, it won't affect the surface that much. That was the conclusion. Okay, but others have done work after many people using full GCM, okay, and trying to understand the role of heat source and the ambient wind. And I think the point about that is, if the low level wind here is necessarily okay, then the descending motion is to the right. The lower level wind is easterly, it pushes to the side. But that I have to look a little more carefully. But the work done so far, I'm not fully understood that. I will talk about it in the next few days. Let me see, I missed something here. Oh, I think I brought the long slide here. So I want to show a work of Annamalai and Prasanna on mass static energy budget. Somehow I seem to have missed it here. Sorry, it is not in this. I brought the wrong slide. So another way to understand the whole thing is to do a mass static energy budget over the period of the break. Okay? Now the problem is, you published a paper about 10 years ago, 2012. Now at that time, this ERA interim, not ERA 5. The mass static energy budget is not closing. Okay, the large residue. So I find it very difficult to understand. Next time I will show you. If the residue is that large, then I don't know what comes through. Okay? So his main conclusion was that just before the break, as the clouds weaken and you get more clear sky like today, OLR increases. Okay, that's obvious. No cloud OLR. OLR goes up, then going by the Nealon hypothesis, the net radiation at the top of the atmosphere is S into 1 minus alpha minus OLR. Okay? So this goes up, this will go down. Okay? And according to Nealon hypothesis, based on what I method, P minus E is proportional to Q net. Okay? So its logic is this increases and hence Q naught goes down, that decreases rainfall, and that is a chain reaction. Now, the only problem in this work, I'll go back and check again, is showing this is decreasing. Now, that bothers me because this means S cannot change, alpha is increasing. I cannot see how can alpha increase when you have a break. I can't understand. Okay? Because you remove the clouds, albedo will go up. Other currents are, that will doesn't matter. In India, I don't albedo can go up. So that part I will check. Something is not right about that. We'll check it next week. We will discuss that. Something to be looked at a little more closely. But this part is right. As the clouds go down, OLR goes up, it reduces this. But if this joins that, it will be then rapid. That's what he's showing. But I need to check that out. Then he shows, because a couple of things happen, which because there's one term, stability term, the denominator, that goes up because the vertical whatever transfer is not there. So that point is made based on about 10 breaks. Okay, so I'll discuss that next week. Yeah, now how I missed that slide, unless it's still there. Let's see. I think I took the wrong. It's not here. I thought I cut and pasted it, but I didn't do it, I think. It's missing. Okay. So it's published in Journal of Climate. Here we can look at it. The Journal of Climate publication 2012, Prasanna and Annamalai. Okay. So who is coming next week? Okay. Fine. We'll meet next week and see what the forecast is like.